Hi you guys, today we're going to start 11.3 from our book, but we're going to do it in two parts. The second part we'll do next class because this is already a lot, okay? This I put on here, you will use this, the Pythagorean theorem, in some of your work, so I'm just reminding you of it in case you need it. And it will also help you, right, for your final anyways. Okay, remember that this box always sits on or points to the legs. Okay, so that's it. Just remember it's Pythagorean theorem, and you will have to use it. I would start by labeling your legs and your hypotenuse so that you do it correctly. Okay, I'm going to do a real quick, I'm not doing problems, but I am going to write out the ratios. So, it has to be long O. Ka, it's got to be A, like soka toa, like you're soaking your toe in the bathtub. Okay, and it's soka toa. So you got to go sine, and you have to put the angle symbol. Say you don't, and you just put sine equals, and you go in order. So next is O for opposite leg, has to go on top. Hypotenuse has to go on bottom. And you have to put angle right here. Okay? Okay, so it goes sine of the angle equals opposite leg over hypotenuse. You have to leave space for the angle. Then ka, right, is cosine of an angle, again you have to have the angle, equals adjacent leg over the hypotenuse. I'm just going to put abbreviate, okay? And then if you need to write it out, do it. And then tangent of an angle equals opposite leg over adjacent leg. Okay. So that's just a review. You will see that on only a couple problems. Area of a rectangle, that hinges, everything hinges on that. Area equals length times width. Okay, remember area means the number of square units within the shape, right? It's square units. So it will be measured by inches squared, feet squared, or you can write squared inches. It doesn't matter. And it's talking about these. It doesn't mean to square the length. It's telling you how many squares are in the shape. You might see instead of length and width, they might call it base and height. Doesn't matter. You just multiply these two dimensions together, and that will tell you how many square units are within the shape. You do have to know that. That's an expectation. You should know it for life. Okay, area of a triangle. I'm doing this. You don't have to draw this. I'm explaining it. If you look at this, okay, the area of the triangle compared to the area of the whole rectangle, right? Area of rectangle, and then compare it to the area of the triangle, okay? These two triangles are congruent, so the triangle is 1/2 of the rectangle. It's always like that. Now, you have to use always the height and then the base, but it's the same idea, right? Instead of width times length, a lot of times they'll call it base and height. Okay? And it's always half of that rectangle. So area equals 1/2 times the base times the height. Some of you will not like doing the 1/2, so you could just go area equals base times your height divided by 2. Or, like I said, length times width divided by 2, whatever you want to call those two dimensions. Now, this might throw you a little bit, so let's just show you, okay? If you have, let's make this into a rectangle, okay? And we're talking about this whole rectangle, the whole rectangle. Okay? Because this triangle 1 is congruent to this triangle 1, this triangle 2 is congruent to this triangle 2, that means that the triangle that we're trying to find the area of is still equal to 1/2 the base times the height. It's still 1/2 base times height. It doesn't have to be a right triangle. Any triangle, the formula is always area equals 1/2 base times height, or area equals base times height divided by 2. Taking 1/2 and dividing by 2 are the same. Now, here's what you have to pay attention to, and I want you to circle this. In your picture, to find the height, to find this height, you always have to look for the perpendicular. That's how you find height, okay? Look for the right angle, you guys. You have to look for the right angle to find the height. So this number won't mean anything. This number won't be anything. You have to know how tall is the height to the base. We'll practice more of those. Okay, so there's that one. Area of a rhombus. You talked about rhombus and parallelograms, rectangles, and squares in first semester when we studied quadrilaterals. A rhombus is a four-sided polygon, which is called a quadrilateral, and all four sides are equal, always. Okay? These lengths may not be equal because it could be a real squishy one. Okay? Like you squished it in. So all that I know is that the four sides have to be equal. Okay? These will always be perpendicular, always. These are called your diagonals. They go from boxing corner to opposite boxing corner. That's a diagonal. Diagonal. Okay? Diagonals are perpendicular always. Here's the other thing that's really important. The diagonals bisect each other. So this half of the diagonal equals this half of the diagonal. This half of the diagonal equals this half of the diagonal. The diagonals bisect each other. Okay? This you don't have to draw, just watch me. If I make this, I square it out again like I did the triangle. I'm going to go ahead and make it into, not a square, a rectangle. Okay? Okay. If I talk about this whole rectangle, okay? So I'm just going to do it quick. This triangle, okay, is the same as this triangle. This, same as this, same as this, same as this. So what that means is that the area of this rhombus is half of the area of the rectangle. So if we multiply the base times the height, or the length times the width, whichever word you choose, that will be the area of the whole yellow rectangle. And if I divide it by 2, it'll give me just the area of the rhombus. So that this is the diagonal right here, which is the base. This is the diagonal right here, which is the height. Okay? So instead of calling them base and height, I'm going to call it diagonal 1 and diagonal 2. If you followed, you did. If you didn't, it's okay. And it goes like this. Area of the rhombus equals 1/2 diagonal 1. Oh, put a times in here. When they're matched, it means multiply, but I'm going to write it to help you. Times diagonal 2. Some of you will not like having 1/2. So you can also say area equals the one diagonal times the other diagonal. Instead of multiplying by half, let's just divide it by 2, because it's half of that full rectangle. I am just giving you formulas. I am not doing the problems. We will do a couple together, and that's all. Okay, now this is a kite. This is a kite sideways. I'm going to turn my paper, okay? This is how most of us are used to seeing a kite, right? You fly a kite. This equals this. They both have 2 hash marks. This length equals this length, 3 hash marks. This is the axis of symmetry. If I were to fold it over, 1/2 equals the other half. Now, this is exactly the same logic as talking about the area of a rhombus. Okay? These triangles are equal. These triangles are equal. These triangles are equal. These triangles are equal. So if I want the area of just the kite, okay, I want just the kite, that means I would take the area of the whole rectangle, which is diagonal 1. This is a diagonal, boxing corner to boxing corner, right? Times your other diagonal. That's your length and your width. Your, you could call it your base and your height, whatever letters you want to call them. But here, in this, we're going to say diagonal times diagonal, and we're taking half of it. It will be the same formula. So let's flip this back. So when we do this, a kite could be on its side. The kite could be this way. I'll just draw a quick one over here. Okay? This. Okay, we're going to talk more about the kite in a second. Okay? So area is exactly the same as the area of a rhombus. Same exact thing. Area equals 1/2 times diagonal 1 times diagonal 2. Or you could say area equals diagonal 1 times diagonal 2 divided by 2. They are the same thing. Okay? Now, when you're working with a kite, so you could see on this, if I draw in the diagonals, okay? This, like when you fly a kite, right? This length is going to be the same as this length. So that means when I turn this sideways and look at it, right, the kite this way, this length equals this length. And this also, these are all going to be right angles in here also, just like on the rhombus. The diagonals are perpendicular to each other. So you could do some SOHCAHTOA trig in there. You could do some Pythagorean theorem inside these right triangles to find numbers that are missing. Big thing to remember, like if this is 5 long, then this would be 5 long, and the whole diagonal is 10 long. But this length is not the same as this length. Only in a rhombus are they both equal, right? This half equals this half. This half equals this half. That's what makes this a rhombus. But on this one of these lengths has to be longer. If they're the same, it would just be a rhombus. Okay? Again, these are perpendicular. Okay? I'm not going to do examples with this. Not now. We'll just do them in the work so I could talk less. Area of a parallelogram. Area equals, and it can still be length times width, base times height. I'm going to use base times height. We're multiplying the 2 dimensions together. Okay? I'll show you real quick, some quick logic, nothing fancy. If I chop off this triangle right here, that would be the same as this triangle right here, and I can make this thing into a square, a rectangle, sorry. This would be the rectangle, okay? That's why it's still base times height, okay? This triangle is the same as this. You could cut it up, make it into a rectangle. I'm going to redraw it the way you had it originally so I could talk about the height. Okay. This is my height. This is my base. When we do this, opposite sides are congruent. I mean, they're congruent and they're parallel, right? So this would be my base, which is also means this is my base. They're the same. This is your height. You guys have to pay attention to the right angle. You have to watch this. Right angle stuff. That's a big, big, big deal. Where you see the right angle is where you'll find the height. Okay? Look for this again. Okay? Look for your right angle. Now, over here, we call this S. This is called my slant height, but we'll talk more about that later. You'll get that later. Okay, trapezoid. Now, we know your basic formula is always base times height. But this one's crazy. I got two different bases in here, right? So instead of going area equals base times height, I'm going to go, it's the average of the two bases. Add the bases together. Base 1 plus base 2 divided by 2. And then it's times your height. Notice again, we're looking for the right angle. Times the height. Okay? You may see it written this way. Area equals 1/2 times base 1 plus base 2. That's the same thing as adding them and dividing by 2. These are the same. Times your height. Okay? All the same. And then the last thing to remember, perimeter is underlined rim. This is like the fence. This is the length around the shape, okay? It's like the fence, and you find it by adding lengths of all sides. Okay, that's all you do. I'm not going to spend a lot of time on perimeter. You're just adding the lengths of the sides. We'll talk about it though. Okay, let's flip it over and let's do a couple problems. Okay, at least talk them through. So over here, triangle. I know that the area of a triangle equals 1/2 times base times height. So my big question is, which is my base and which is my height? So I look for my right angle, okay? You guys can turn it sideways. You could go, oh, yeah, I see. This would be a rectangle right here, right? Oh, that's an awful rectangle. Okay, say it's a rectangle. And I could go, I'm going 1/2 base times height. That's all I'm doing. Let's erase it. That looks awful. Okay, but that's okay. You guys got it. Okay? So area is 1/2. This we're not using. We don't have to use. So we're just going 1/2, 40 times 9. That's all I do. 40 times 9 divided by 2. This is so that's for a triangle. This is for a kite. I know that it's a kite because these two sides are equal length and these two sides are equal length. For a kite, it's 1/2 times diagonal 1 times diagonal 2. Well, this 25 is the length of this diagonal. What is the length of this diagonal? Because we said the diagonals bisect just this one going across, right? This one part here, I'll put 3 hashes because I got 1s and 2s already used. This half equals this half. So if this is 10.1, this is 10.1. So 10.1 plus 10.1 or 10.1 times 2 gives you this. Then we're going to plug it in. Okay. Number 3, again, it's a triangle. Area of a triangle, right, equals 1/2 times your base times your height. Well, I need to know then, this right angle tells me my base and height. I don't need to know this, but I have to know this base. In order to do that, I'm going to have to use that angle. So I'm going opposite leg, box sits on the leg. Remember, you take it, you keep going across till you touch it. That's your opposite leg. This is your adjacent leg. I don't need the hypotenuse. Opposite leg and adjacent leg is tangent function. You're going to use your tangent of 62 to find this base divided by 19. Once you find that, you'll plug it back in and use that formula. Okay, so the big thing is really just understanding what the shapes are. I should have marked stuff on here. Okay, this is a parallelogram, sorry. Okay, so you're going, a parallelogram is just base times height. Because this triangle could come off right here, right? And turn that into a rectangle, right? So it's base times height. Number 5 is harder. This is a rhombus. A rhombus, the area equals 1/2 diagonal 1 times diagonal 2, right? Multiply them together. Or you could say diagonal 1 times diagonal 2 divided by 2. But this one's hard. I only know this diagonal length. I do not see on here this diagonal length. In order to get that, we are going to use a right triangle. So we're going to use this right here. Okay? And I've got, this is 20. I know the diagonals are perpendicular to each other, and I know they bisect each other. So this half equals this half. The whole length is 24. 24 divided by 2 means this is 12 high. This triangle here is 12 high. So this is 12. This is my right angle. Leg, leg, hypotenuse. Leg squared plus leg squared equals hypotenuse squared. Find this number, multiply it by 2, and that'll give you the length of the other diagonal. Number 6 is another one, a little bit hard. Area of a triangle equals 1/2 base times your height. And I said you have to look at the right angle to find your height. So I have to know this. That'll be my height. And then this whole thing will be my base. So what you're going to have to do is use trig. Right here, use trig. Okay? I know this is 6, so I'm going to bring it over here. Okay? This is, 6. I'm going to put an H here for height. B here for base. This is 22.5 degrees. So you're going to have to use SOHCAHTOA. The box points to the leg. Take the angle, go, 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 till it stops. This is my opposite leg, so that means this leg has to be my adjacent leg. This is hypotenuse. Just do one of these first, which opposite leg and hypotenuse, find this side. Then use just the adjacent leg and hypotenuse. Find this side. That'll give you your half of your base. You have to multiply by 2, and your height to find the area of the triangle. I'm going to do just this one, number 8, and I'm going to stop. Okay? Number 8 says, what's the area? This is a trapezoid. I've got 2 parallel sides only. That's what makes it a trapezoid. Okay? Area equals, add the bases together. The sides that are parallel are called bases. This is a base, and this is a base. Let's go fill that in. Flip this over. Let's do that real quick. On this, the 2 sides that are parallel, I should have written, parallel sides are always the base. Okay? Bases are always the parallel sides. And then your height is the distance between the 2 bases. And remember, there will always be this right angle here. Right angle, okay? your height will have a right angle, is the distance between the bases. Okay, so if I put a number here like 16, that is not the height. It has to be the perpendicular. So 16 is not the height. There is no right angle. This side is not perpendicular to the base. Okay, so bases are always the parallel sides. The height is the distance between the bases. Okay, let me flip it over on this side. Okay, this, because of the right angle, this is my height. The height is the distance, right, between the two parallel sides, the bases. So you could either go 1/2, right? Add your bases together, base plus base times your height. So I'm going to put base 1, base 2, or area equals base 1 plus base 2 divided by 2 times height. Either way, you're going to put in here 3.6 and 6.4. Use your parentheses when you type it in your calculator. Okay, that should be enough to get you guys started. Okay, ask me questions in class. Thanks for working hard.